Hey there guys, today we're going to be learning about translation vectors. So another name that they could be called are transvectors or glide reflections. So what we're going to do is you need to make sure you do the warm-up before you get into the notes. I will do the warm-up with you on this video just in case you were struggling with it. It's just a little bit of algebra review. And then we'll get into our transvectors. For the warm-up, we need to solve for x for each one of these. So on this first one, we need to make sure that we distribute that 6 to both terms in the parentheses, giving us 36x minus 66, all equal to 150. Then it's just all about getting your x by itself. So I need to get rid of the minus 66 by doing the inverse and adding 66 to both sides, leaving me 36x equals 216. And then to get x by itself, last step, we need to do the inverse of multiplication, so divide both sides by 36. And I do not know what 216 is divided by 36 is off the top of my head, so I got to get out my handy dandy calculator. $216 divided by 36 gives me 6. So our answer is x equals 6. For number 2, distribute first. We have 300 is equal to 50x minus 100. Then worry about getting x by itself. So instead, since we have minus 100, to move that to the other side, we do the inverse, add 100 to both sides. So 400 equals 50x. That's 50 times x, so to get rid of the 50, we do the inverse of multiplication, so divide. Divide both sides by 50, and you have 8 for our x. Number 3, we have variables on both sides, so we need to get all our x's on one side. I'm going to go ahead and add 9x to both sides. However, if you subtracted 1x from both sides, that would have worked too. We'll end up with the same answer. So that gives me 10x minus 42 equal to 98. Working towards getting those x's by themselves, so we'll add 42 to both sides. 98 plus 42 gives me 140. Divide both sides by 10 and you are left with x equals 14. For number 4, we need to get, again, we have variables on both sides, so I need to get all my x's on one side. I'm going to subtract 5x from both sides, but if you subtracted 9x from both sides, you will get the same answer as well. So we get negative 41 equals 59 plus 4x. Need to get those x's by themselves, so I'm going to subtract 59 from both sides. Negative 41 minus 59 gives me negative 100. So we have negative 100 equals 4x. To get x by itself, divide by 4. So x equals negative 25. So that's how we get our x's by themselves, or solve for x on linear equations. The next 4 problems I'll have to do with quadratic equations. So this is where you have to get everything on one side, have the other side set equal to 0, and then factor. Remember, since this is a video, anytime I go too fast, you can just pause the video and then catch up and then start it back up again, or you can always rewind. Alright, so in this case, everything is already on the left side. So anytime you see an x squared, you need to have everything on that side, the other side equal to 0. So since that's already set up for us that way, we need to factor. The way we factor is we got to find two numbers that multiply to give me a negative 27, but add together to give me a positive 6. So I need to write my multiples of 27 out to the side. 1 and 27, 3 and 9, and I think that's it. Now, since it's a negative 27, that means one of our numbers has to be positive and one of it has to be negative. So we look at this sign. Since it's a positive 6, that means when they add together, they give me a positive number. So that means the bigger number has to be positive. So that means it has to either be negative 1 and 27 or negative 3 and positive 9. So in this case, the set of numbers that will add up to give me a positive 6 is negative 3 and positive 9. So I've set my factors up as x minus 3 times x plus 9, because that's a positive 9, equal to 0. Then it's just a matter of setting those two equal to 0 and solving for x. So x minus 3 equal to 0, x plus 9 equal to 0, get x by itself. So in this case I get x equals positive 3. In the second case I get x equals negative 9. Now it can't be 3 and 9 at the same time, so that's why I put the or in between. So x either equals 3 or x equals negative 9. In this case on number 6, we have x squared plus 17x equals negative 70. Since we have an x squared, we need to get everything onto that side. So I'm going to add 70 to both sides so that will have a 0 on the right hand side. So x squared plus 17x plus 70 equal to 0. Now I can go ahead and factor. So I need two numbers that will multiply to give me a positive 70 and add together to give me 17. So I write my factors of 70 out to the side. We've got 1 and 70, 2 and 35. 3 does not go into it evenly. 4 does not go in evenly. 5 and 14. 6 does not go in evenly. And then our last one will be 7 and 10. All right, so those are all my possible factors for 70. Since this is a positive 70, either both numbers have to be positive to get me that positive 70 when I multiply them, or both have to be negative, because a negative times a negative does get me a positive. So then I check here to see what sign this is. Since that's positive, then they'll both be positive. All right, so now I just need, since they're both positive, they're already marked positive, I just need the two sets of the two numbers that will add up to give me 17. And in this case, 7 and 10 will add up there. So we've got x plus 7, because it's positive 7, x plus 10, because it's positive 10, set equal to 0. Set each one of those equal to 0 and solve. X plus 7 equal to 0, x plus 10 equal to 0, and then get x by itself. So we get x equals negative 7, or x equals negative 10. So those are my two possible answers for x for that one. For number 7, it's already set equal to 0, so I don't have to worry about getting it set equal to 0. So I need the factors of 4, because I need two numbers that multiply to give me positive 4, but add up to give me positive 5. So we've got 1 and 4, or 2 and 2. Since it's a positive 4, that means they either both have to be positive or both have to be negative. Since this, so we look at this sign to tell us what they're going to be. Since that's a positive 5, that means they're all going to be positive. So I need the pair that will add up to give me 5. So that's 1 and 4. So that means it's going to be x plus 1, because it's positive 1, x plus 4, because it's positive 4, set equal to 0. Set each one of those equal to 0 and solve. Oops, don't need that parentheses. And what you'll notice is you basically get the opposite sign. So when I set x minus 3 equal to 0, I get x equals positive 3. When I set x plus 9 equal to 0, I get x equals negative 9. So you're basically just getting the opposite sign. So if you want to skip that step and just write x equals negative 1 or x equals negative 4, you are welcome to do that. However, I like to show every step of my work, so I'm going to show you how I get there. So x plus 1 equal to 0, x plus 4 equal to 0. Subtract 1 from both sides, and you get x equals negative 1. Subtract 4 from both sides, you get x equals negative 4. So those are my two possible answers for that one. Negative 1 or negative 4. Last but not least, it is already set equal to 0, so we don't have to worry about that. We just got a factor. We need factors of 21, and we need those numbers to add up to give us a negative 10. So factors of 21 would be 1 and 21. 2 does not go in evenly. 3 goes in 7 times. And those are all my factors. So I need them to multiply to give me a positive 21. So that means they either both have to be positive or both have to be negative. So I look to see what sign this is. It's negative, so that means these numbers have to be negative. So I need the pair that will add up to give me a negative 10. So that would be negative 3 and negative 7. So I set that up as x minus 3 times x minus 7 equal to 0. And then set each of those equal to 0 and solve. So in this case, I add 3 to both sides, getting me x equals positive 3. Add 7 to both of these sides, giving me x equals positive 7. So x will either equal 3 or positive 7 for that situation. Alrighty. Warm-up's done. If I went too fast, rewind, pause, whatever you got to do to get caught back up. And then make sure that you turn your warm-up enclosure into the bin once you're done with the closure. Remember, the closure's on the back. Can't do the closure until you've gone through the notes, though, so you know what you're doing. So moving on to our notes. Let's see what our objective is for today. We will learn to use vectors as transformations in order to complete translations of figures on the coordinate plane. So what that means is we're going to translate them. There'll be an arrow on our images on our graph that'll tell us how they want us to slide that image, or they can give us the notation for it and we figure it out that way. So going back to my notes, say vectors are just going to move our points. So what are the coordinate images of 1, negative 2 under the vector of 3, 4? So notice how it looks like parentheses, but they're pointed. That's when you know that they're vectors. That's what the notation for vectors looks like. So we're going to actually be, that's not an ordered pair. It's not a point. That's telling us what we need to do to our coordinates over here. Whatever's in the x coordinate position, you're going to do that to this x coordinate. Whatever's in the y, you're going to do that to this y coordinate here. Since this is a positive 3, that means they want us to add 3 to that x coordinate of 1. And since that's a positive 4, that means they want us to add 4 to that y coordinate of negative 2 to get our new ordered pair. So 1 plus 3 gives me 4. Negative 2 plus 4 gives me a positive 2. So under this vector, it moved this point 1, negative 2 to the point 4, comma 2. And that's what the vector does. It helps us to move points. So our next example, what are the coordinates of the image of the point 1, negative 2 under a vector of negative 1, 6? So that negative 1 means we're going to subtract 1. Instead of adding 1, it's like these were both positive, that's why we added. Since that's a negative 1, that means we're going to subtract 1 from our x coordinate because it's in the x coordinate position. And since that's a positive 6, we add 6 to our y coordinate because it's in the y coordinate position. To get our new point, 1 minus 1 gives me 0. Negative 2 plus 6 gives me a positive 4. So that vector moved the point 1, negative 2 to our new point of 0, 4. So these would be our pre-image points, and these would be our image points. What are the coordinates of the image of 1, negative 2 under a vector of 0, 2? So if you get a 0, nothing's happening. You're not adding 0, or you're not adding anything, you're not subtracting anything. So that means if you physically want to write something here, you can put plus or minus 0. It's not going to make a difference to that x coordinate. For the 2, since it's positive 2, we add 2. So 1 plus 0, same number, just stays 1. Negative 2 plus 2 gives me 0 for my second coordinate, for the y coordinate. So under the vector of 0, 2, it translated the point 1, negative 2 to the point 1, 0. Number 4, explain using mathematical reasoning what the coordinate of the image 3, 6 under a vector of 2, negative 1 becomes. It's basically When they say mathematical reasoning, it just means show your work. You can write it the way I've been writing it. I would accept that as mathematical reasoning. Or you can write a paragraph, sentence or two explaining what you're doing here. Since that's a positive 2, you could say under the x-coordinate of 3, I add 2, since the vector was positive 2, and for the y-coordinate, I subtract 1 because it's a negative 1. If you want to write that, you're welcome to do that as well. But when they say mathematical reasoning, it's basically just showing your math that you're doing, showing your work. So you could write it the way I've been doing up here. I'll give you a couple examples of the way we can write this as far as using mathematical reasoning. You can write the point 3, 6. And then since it's a positive 2 here, putting a plus 2 under the 3 because that's in the x-coordinate position. And since that's a minus 1, or a negative 1, we can put minus 1 here for the y-coordinate position. And then show that 3 plus 2 gives me 5 for my x-coordinate. 6 minus 1 gives me 5 for my y-coordinate. And then just circling your answer, or boxing it. Another way you could write it is writing as a big ordered parentheses here, 3 plus that 2, comma, 6 minus that 1, and just writing your 5, 5 this way. Either way would be acceptable. It's showing your work, showing how you got there. Whichever way you're most comfortable with. As long as you get that final answer and you show your work, that's good enough for me. All right, now as far as seeing a vector on a graph, we've seen the notation for it, but now as far as seeing it on a graph, let me find my notes, see if we had pre-images on here. Okay, so we're going to write down what I'm going to give you points, and we're going to write down what those pre-image points coordinates are. I'm going to give you the vector. Well, we can see it from the graph. We'll figure that out from that, and then we're going to figure out where that new point's going to go. So I'm going to give you point A, and it's going to be located at 1, 2. So after you write down the A, our pre-image is at 1, 2. I need you to go ahead and graph that. So to the right 1, up 2, there's our A. Okay? So we've got our pre-image now. Next, we need to write our notation for our vector. How we figure that out is based on that arrow that you see on the graph. So how we figure that out is we need to figure out our x-coordinate for our x vector, what we're doing to our x-coordinate. We need to see how far we go left or right. Okay, so since this would be your starting position of the arrow, this would be your end. Okay, if you want to write S and E to show start and end, you're welcome to do that. So if you start here, x coordinates always show how much we go left or right. So it looks like we're going to the right 1, 2, 3 points. So that's a positive 3 because we're going to the right. And then from there, so we went right 3. So it's positive 3. And then we're going up 2. So since we go up, that's positive. If you went down, it would be negative. Oops, I put negative, but I was thinking positive. So positive 3, positive 2 is our vector. So now we need to do that to this point A. So we're going to go to the right 3 and then up 2. 1, 2, 3, up 2 to get to our A prime. So our image is A prime, and you just need to write those coordinates down for that point. You can either figure it out by adding 3 to that 1 to get 4, and adding 2, because this is a positive 2 for our vector, to this 2 to get 4 as well. Or you can look off of your graph, 1, 2, 3, 4, 1, 2, 3, 4. And that's a way to double check yourself. Make sure you got it right. All right, let's do another one. I'm going to put, for the second one here, point B. Somehow we lost our pre-image information here. So I'm going to write pre-image is point B at negative 3, 4. I'll go ahead and write in my vector here. And then my image down here. And we'll fill that in. All right, so plot your point B at -3, 4. So that means -3 means we're going to the left 3. +4 means you go up 4. Plot that point B. So that's our preimage. Now we're going to use our vector that we see from this arrow to show how we're going to shift that point B to B prime. So this is the beginning of my arrow, so that's where I start. This is my end of my arrow, so that's where I end. So going from my starting position, I first go left or right for my X. So it looks like I'm going to the right 1, 2, 3. So when you go to the right, that's a positive direction for your X. So +3. And now we're going down 1 unit. So that's a -1. When you go down, that's negative for Y's. So our vector is 3, -1. So then we need to figure out where does our image at. So B prime, -3 plus 3, because that's a +3, gives me 0. 4 minus 1, because that's a -1, gives me 3. So I plot the point 0, 3. 0 means I don't go left or right. +3 means I go up 3. So that's my B prime. And you can see how it shifted that same direction the arrow pointed. We went to the right 3, down 1 to check yourself. Alrighty, let's do another one. Again, if I go too fast, pause, rewind, do what you got to do. Okay, we're going to put point C at -4, -1. So going to the left 4, 1, 2, 3, 4, down 1 because it's a -1. So that's C. And based on our vector, we're not going to the right at all or to the left. So that means since it didn't go right or left, that's a 0 for our X part of our vector. And then we went from start to end. Looks like we went down 1, 2, 3. So since you're going down, that's -3. So going down 3 from here, 1, 2, 3, there's my C prime. And then the coordinates of C prime, -4 minus 0 gives me 0, or sorry, gives me -4. -1 minus 3 gives me a -4. So we have -4, -4. And let's just double check, see if that's where it ended up. 1, 2, 3, 4, 1, 2, 3, 4. Perfect. One more example. We've got point D, which is going to be at the point 1, -1. So plot that point. +1 means we go to the right 1, -1 means we go down 1. So there's D. Now this vector goes left. Here's my starting point. My ending point is where the arrow point ends. So we're going to the left 1, 2, 3. So since that's to the left, that's negative for the X. And then it doesn't go up or down any, so that's a 0 for the Y. So D prime, 1 minus 3 gives me a -2. -1 plus or minus 0 still gives me just -1. So at the point -2, -1, that's our D prime. And then you can tell, based off of this, we went to the left 3, go to the left 3, that's where we end up. So that's just a way to double check yourself, make sure you got it right. Alright. On your next page, we're going to have, instead of just points, we're going to have whole figures. So in this case, a triangle. And then you see the notation at the top. So we've talked about using lowercase r for reflection, uppercase R for rotations, dilations. We had, it would tell us the scale factor by using K. It was a size change, so it was capital S for size change, and then the lowercase k, or the underneath it, told us what our scale factor was. In this case, our notation is a capital T for transvector, and then down here, that tells you it's a vector. Alright, so we're transvectoring, and when it has that V with a little half of an arrow above it, that means you got to base it off of the arrow here. It's going to tell you where to go. So we're doing triangle EHS and trying to create triangle E prime, H prime, S prime. So first things first, they've given us our E, H, and S coordinates. We need to find our E prime, H prime, and S prime coordinates. So I'm going to look over here and see what this vector is. So here's my starting point. Here's my ending point. So left or right, looks like we're going to the right 1, 2, 3, 4. So since we went to the right, that's positive 4. And then we're going up 1, 2. So since we went up, that's positive 2. So our vector is positive 4, positive 2. So I'm going to put that below each one of these coordinates here, so that I know that's what I have to do to each of these to get my new ordered pairs. So since it's positive 4, positive 2 for each of these, that means we're adding these. So negative 5 plus 4 gives me a negative 1. 1 plus 2 gives me a positive 3. So E prime will be at the point negative 1, positive 3. So there's my E prime. You're welcome to graph it now, or you can wait until you get all 3 coordinates. It's up to you. So for H, we're taking 0 plus 4 because it's positive 4. So that's 4. 4 plus 2 gives me 6. So I got the point 4, 6 for my H prime. So from the origin, I go to the, since it's positive 4, go to the right 4. And since it's positive 6, we go up 6. So here is my H prime. And then last but not least, negative 3 plus 4 gives me positive 1. Negative 3 plus 2 gives me negative 1. So at the point positive 1, negative 1 is my S prime. From there, you want to connect all 3 points and then highlight your image so that we know that's our image and the other one is our pre-image. And as you can see, looking at the arrow and looking our pre-image to our image, you can see we shifted it just that much and in that direction. Another way you could have gone about it was figuring out this is to the right 4, up 2. I could have just gone 1, 2, 3, 4, up 2. There's my S prime. For E, 1, 2, 3, 4, up 2. There's my E prime. For my H, 1, 2, 3, 4, up 2. There's my H prime. And then I could have figured out what those coordinates were and put them over here. So there's 2 ways you could go about it. Both ways get you to the right answer. And that's another way you can check yourself if you know both ways, just to make sure you're getting them right. All right, so let's get down to working without a graph and just working with notation to figure out our new points. So if you look down here, it says write the coordinates of each point under the transformation described. Part A says give the new coordinates of 10, 3 under the transformation, that's what that capital T means, of 3x and then y minus 4. So they're telling you exactly what they want you to do in the here. So for the x position, they're wanting you to take 3 times whatever your x is. Since they're right next to each other, that means we're multiplying here. So we got to take 3 times whatever our x is. Well, our x is 10. Remember, this is your x, this is your y. So 3 times 10 is how I'm going to get my x coordinate. So that gives me 30. For my y coordinate, we're taking the y minus 4. So if my y is 3, then to get my y coordinate, I take 3 minus 4. That gives me negative 1. So my new ordered pair, x comma y, is 30, negative 1. So this would be your new coordinate. For part B, give the new coordinates of negative 1, 6 under the transformation of x minus 1 and then 4y. So that means we're taking our x coordinate, which is negative 1, minus 1. So we'll have negative 1 minus 1, which gives me negative 2. And then our y coordinate, we're taking it times 4. Remember, when the 4 and the y are right next to each other, that means they're being multiplied. So 4 times whatever my y is, well, my y is 6. 4 times 6 gives me 24. So our new coordinate would be negative 2, comma, 24. Part C, give the new coordinate of 5, 1 under the transformation of x plus 3, y minus 1. So that means we add 3 to whatever our x is. Well, our x is 5. So 5 plus 3, and that gives me 8. And then y minus 1, my y is 1, so 1 minus 1 gives me 0. So our ordered pair for our new coordinate is 8, 0. Part D, give the new coordinates of 9, 1 under the transformation of x minus 4 and 2y. X minus 4 means we take our x coordinate and subtract 4. So 9 minus 4 gives me 5. For 2y means we take 2 times whatever our y is. Well, our y is negative 1. So 2 times negative 1 gives me negative 2. So our ordered pairs, 5, negative 2. Alrighty. Hope you get the gist of that. All right. Now on the next page, our problem is, we're going to do more than one transformation. It says reflection of across the x-axis and then doing a transvector for FUN. FUN is going to be our pre-image that I'm going to draw on here for you. So you got to draw the image or the pre-image first. So let's do that before we start getting into actually what we're doing to it. So I'm going to put F at negative 5, 1. I'm going to put point U at negative 3, positive 3. And then I'm going to put N at negative 1, 0. So go ahead and plot those 3 points and then connect them using your ruler. And this is going to be your pre-image, which I usually have on there for you already, but on the computer it would not let me do it. So instead of drawing these in prior to making my copies, it is what it is. We're going to draw our own. So there is my pre-image. F at negative 5, positive 1, U at negative 3, positive 3, and N at negative 1, 0. So now that we have our figure, our pre-image, FUN, remember, when we are doing more than one transformation, that little circle there means we're going to do this transformation, we're going to do this transformation. Whenever we're doing more than one to an image, we work our way from the parentheses on out. So that means we're going to do this vector first, and then we're going to do the reflection across the x-axis. So our vector, we got to draw that in too, because you don't know what it is yet. I'm going to draw it down here. So draw that vector in so that you can see what shift we're going to do. Excuse me. All right. So our vector is showing that we're going to go to the, if this is my start and this is my end of that vector, we're going to go to the right 2, down 1. So I'm going to do that for all 3 of my points up here. So we go to the right 2, down 1 for each one. So I'm going to start with N, going to the right 2, and then down 1. This will be my N prime. Going to U, to the right 2, down 1. That'll be my U prime. And for F, to the right 2, down 1, puts my F prime right here. Go ahead and connect those 3. But do not highlight because we still have to reflect it next. This is just our first transformation. You're doing the transvector. So we shifted it to here. Now we have to do our reflection across the x-axis. So you're done with your pre-image now. We're not reflecting that across the x-axis. You're now reflecting F prime, U prime, N prime across the x-axis. So with reflection, since this is my reflection line, the x-axis, that means whatever distance my N prime is from that line, I need to go the opposite direction and have that same distance. So if N prime is 1 below my x-axis, then my point for my reflection of n prime is going to go there. However, so I go ahead and put that there, but don't call it n double prime because this will be my final point for my n. However, they want me to call these new letters, my image letters, PIE instead of F double prime, U double prime, N double prime. So remember, order matters. F is going to become P, so my F prime is going to become P prime, or sorry, P. My U prime is going to become I, and then my N prime is going to become E after I reflect them. So N prime is up here now, or N double prime would be there, but now since N was the last letter, E is the last letter, I now label it E. I hope that's not too confusing. They just wanted to change up the letters on you. So for our image, we need to label that point E. Alright, now we're going to do U prime. We got to reflect it across the x-axis. So here's my x-axis right here. U prime is 2 units above, so I go 2 units below the x-axis. Now instead of it being called U double prime, we're now calling that, since that's the second letter, we're calling that I, since I was the second letter as well. So I've got I and E. I just need to get my P. Now we got to reflect F across the x-axis. However, F is already on the x-axis. So when it's on the line of reflection, then it just stays in that spot. So I'm going to relabel that point P, because F was the first letter, P is the first letter, so they want me to call that point P. So now I'm going to connect P to I to E. And then once you connect those, you can go ahead and highlight that because that is your image. And this is why we use a highlighter, because we've got a lot of lines on this page here, and we want to be able to tell the difference between our pre-image and our image. And there we go. So we slid that image this direction and then reflected that image across the x-axis. Alright. Down here, they want us to go ahead and answer some questions. Said, what are the components of the vector? What they're looking for there is for you to use that notation to tell them what that vector is. So we had gone 2 to the right, so that's a positive 2. And then we went 1 down, so that was a negative 1. So that was the vector we did. What are the coordinates of P once we reflected F across, did our translation of F and then our transvector of F and then our reflection of across the x-axis and became P? They want to know the coordinates of P now. So P, the coordinates are -3, 0. So write that down. The coordinates of I is -1, -2. Because from the origin, you go to the left 1, so that's -1, and down 2, and that's -2. And then our coordinates of N. N is at +1, -1. Because we went to from the origin, you go to the right 1, so that's +1. Down 1 gives you a -1. There you go. So answering these questions up here, I kind of skipped over them. What did we do versus the reflection of across the x-axis or the vector? We did the vector first because when there's more than one transformation, you work your way from the parentheses out, and then the second one was the reflection. We talked about it, we just didn't write it down. All right. Shall we do another? Flip the page. We're just going to get more and more practice with these. We're going to do 3 more examples, and that'll be your notes for the day. So then you'll have your closure and your homework. I'll try to speed this up. Go a little faster. Okay, so we're going to do the transvector of ICE, and then after we do that transvector, then we do the reflection across our y-axis. So again, we're doing vector first to answer these questions down here, and then our reflection. All right, but you need your pre-image first and your vector. So our pre-image is going to be ICE, which I is going to be at -2, -2. So plot that. C is going to be at -1, -4. Oops, let me scooch it up to where you can see. And then E is going to be at 2, -1. So plot those points. Connect your points using your ruler. There's our pre-image, and then our vector I'm going to draw in this corner here. This being my start, this being my end. Okay, so we had decided based on our notation up here, working your way from the parentheses out, we're going to do our vector first, and then we'll do our reflection across the y-axis. So vector first, looks like we're going to the right 2, up 2. So that's a +2 going this way, and that's a +2 since we're going up as well. So I'm going to go ahead and put that vector components down here. So they were both +2's. Okay. So sorry if I'm moving too fast. I'm trying to make this video not be an hour long, but it might be. So +2, +2 means each one of these points goes to the right 2, up 2. So I to the right 2, up 2 lands here. For now we're calling it I prime because we're still going to do a reflection across the y-axis next. For C, going to the right 2, up 2 lands it here. So that's going to be C prime. And then for E, to the right 2, up 2 means we land up here. So that'll be our E prime. All right, I'm going to connect those. I prime, C prime, E prime, and then we will be done with the ICE. We'll just be working with I prime, C prime, and E prime. So make sure you reflect the correct image across the y-axis. Okay, so we're done with this one. We're now reflecting I prime, C prime, E prime across the y-axis. So it looks like I prime is exactly on the y-axis, so it's just going to stay there. And since I is the first letter and B is the first letter up here, so we're going to relabel this point also as B. Now C prime is 1 to the right of the y-axis, so we go 1 to the left of the y-axis. And C was the second letter, so O is the second letter, so we're going to label that O. And then E is to the right 1, 2, 3, 4 from the y-axis, so we go to the left from the y-axis, 1, 2, 3, 4. And that will be our letter E became X, so we label that one X. So you connect the letters B, O, and X, spelling box, and then highlight that image. Use your ruler so it's nice and neat and pretty. Highlight it so we know that's our image. And then down here they want you to write those ordered pairs for B, O, and X. So B, it's at 0, 0. It's right at the origin. X is at, or let's go, O is at -1, -2. And I'll scoot my paper up in here in a minute so you can see what I'm writing. And then X is to the left 4 and then up 1. So that's a -4, +1. So there's our coordinates. 0, 0, -1, 2, -4, 1. And the more we practice this, the quicker we get with these. We're going to do 2 more examples, then you can do your closure and your homework for the rest of class. Again, if there's anything you missed because I went too fast, you know what to do. Pause it or rewind. All right, flip the page. Okay, in this case, we're going to have duck. We're going to have 4 points to make it that much more interesting instead of 3. And since we have more than one transformation, we work our way out from the parentheses. So we're going to do our reflection first this time across the y-axis. Then we're going to do our vector. All right, so first let's plot where D, U, C, and K are going to be. So I'm going to have D at -3, +3. I will have U at -3, +1. I will have C at -1, 0. And I will have K at -1, 4. Connect those so that we have our pre-image. Okay, and our vector, just so that we have it drawn on here, so that when it does come time for us to do our vector, we're going to go this direction. I'm just going to darken this in a little bit. So there's our vector. This would be the start. This will be the end. All right. So first things first, we're reflecting DUCK across the y-axis. So down here to answer step number 1's question, what are we doing first? Are we reflecting, or are we doing the vector? We're going to do our reflection first. Second, we do our vector. Oops, it would be nice if you could see me. So that's the order we're doing them in, because we're working from our parentheses on out. Alrighty, let's do our reflection across the y-axis. So that means we're flipping it over here. So however far away K is from the y-axis, we got to go the opposite direction, the same number of units. So it's to the left one, so we go to the right one from the y-axis. And we're going to call that K prime. For C, same thing. It's to the left one, so we go to the right one, but down here, that's our C prime. U is 1, 2, 3 to the left of the y-axis, so we're going to go 1, 2, 3 to the right of the y-axis to get U prime. And then D, 1, 2, 3 to the left of the y-axis, so 1, 2, 3 to the right of the y-axis. And there's our D prime. Connect those four so we can see our reflection. All right, so there's our image reflected across the y-axis. Now we can do our vector. Now our vector looks like going from our starting point, we're going left or right, so it looks like we're going to the left 2. So since you're going to the left, that means it's a -2. If you go to the right for the x-axis, you go positive. If you go to the left, that's negative. So that's why it's a -2. As far as the y's, if we go up, it's positive. If we go down, it's negative. So this will also be -2. So for our vector components down here, it's -2, -2. And now we got to figure out where does that put all our points then. So we're going to the left 2, then down 2 for each one of these points. So I'm going to start with my lowest point, going to the left 2. Now remember, we're done with DUCK over here. We're now working with D prime, U prime, C prime, K prime. So for C prime, to the left 2, down 2, puts me down here. And instead of calling it C double prime, look at the location of C. It's the third letter, so the third letter is I. So that's going to now become I. It's very important that you label these properly. U prime goes to the left 2, down 2, because we're doing that same vector for all of these. Now instead of calling it U double prime, U is the second letter, A is the second letter. So that's why we call this one point now A. K prime to the left 2, down 2. Instead of calling it K double prime, it's the last letter, L is the last letter, so that one's L. And then K prime, oh that was K prime, my bad. And then D to the left 2, down 2 places us here. And since it's the first letter, T is the first letter. Boom. There's my letter. So we're going to connect T, A, I, and L, and then highlight that image. so that we can see what our final image is. There you go. So we went from DUCK to TAIL by reflecting across the y-axis and then transvectoring or sliding there. Very nice. Let's go ahead and write our coordinates in for each one of these. It looks like T is to the right one, up one, so that's a positive 1, positive 1. A is to the right one, so that's positive 1, but it's down 1, so that's a negative 1. So positive 1, negative 1. I to the left 1, so that's negative 1. And then down 2, that's a negative 2. And then L to the left 1 is negative 1. Up 2 means positive 2. So to check to see if we have the same thing wrote down, T was at 1, 1. A is at 1, negative 1. I is at negative 1, negative 2. And L was at negative 1, positive 2. One more example. Flip your page, and anytime you feel completely comfortable with this, you can stop the video and finish the rest of these on your own. You are more than welcome. Do not feel like that. I don't want you to be bored while I'm doing my video. If you think you got it, you go on ahead. Oh, the nice thing about this one is instead of changing the letters on us, we can go ahead and call these H double prime, Q double prime, S double prime, R double prime. I like that. All right, first things first. We're going to work our way from the parentheses out. We're going to reflect across the x-axis first, then we'll do our vector. The pre-image is wrote on here this time, however, we still need to put our vector on there. I'm going to draw that first so that we have that done. I'm going to go from here down to this corner here. So this will be my start, this will be my end. All right. So we have our pre-image. First thing we're going to do, reflect across the x-axis. So here's your x-axis. We're going to reflect across this. I'm going to start with S. S is 2 above the x-axis, so I go 2 below. That's going to be S prime. You should know how to do this by now. R is 2 below, so I'm going to go 2 above the x-axis to do my R prime. You always do the opposite. Q is 1, 2, 3, 4 above, so we'll go 1, 2, 3, 4 below, and that'll be my Q prime. And then H is right on the x-axis, so it just stays right there. So that's my H prime. Once you have those all on there, connect them using your ruler so it's nice and neat and not sloppy. There you have our reflection. Now we're not highlighting it yet because we got to do our transvector next. So our transvector, remember, we're ignoring our pre-image. It's not Q, R, H, and S anymore. Now we're working with Q prime, R prime, S prime, and H prime. So we're doing the transvector. It looks like from our start to our end, we're going to the left 3, down 2. So do that for all of these. H prime's here, to the left 1, 2, 3, down 2. That will be my H double prime. For Q prime, to the left 3, down 2. Puts my Q prime right here, or Q double prime here. S prime, to the left 3, down 2. Actually landed right on Q, or Q prime. So that I'm going to relabel that point as S double prime. And then last but not least, R prime goes to the left 3, down 2, puts me right at the origin. So that's my R double prime. So go ahead and connect R double prime to S double prime. Connect S double prime to Q double prime. Connect Q double prime to H double prime. And then connect H double prime to R double prime. And then highlight that image. I know we got a lot going on in there. Just make sure you're highlighting the right lines. And then we're going to write those ordered pairs down towards the bottom. They want to know where those are all located. So H double prime is from the origin 1, 2, 3, 4 to the left, so that's a negative 4 for my x coordinate. and then down 2, which is a -2 for my y. Q double prime is at -1 for my x coordinate, and then down 1, 2, 3, 4, 5, 6, so that's -6. Scooch this up a little bit. S double prime is to the right 2, so that's +2. And then down 1, 2, 3, 4, so that's a -4 because it was down. And then R double prime is right at the origin, so that's 0, 0. All right, that was our last example. I would like you to do your closure and your homework. If you get, well, you definitely need to put your warm-up and closure into the bin when you're finished. If you get done with the homework, you're welcome to put it into the bin as well, and I'll get that next time I'm here on Monday or whenever the next class I have. All right, I hope you guys have a wonderful day and get all your work done. Remember, if you still feel like you're a little confused, go ahead and rewatch this video as many times as possible, or as many times as you want to help until you do get it. All right, have a great day. See you next time.